This little thing can see through walls and detect motion like a radar. Meet the mmWave sensor, perfect for automating lights or a security system in your smart home. The LD2410 is one of the most popular and affordable mmWave sensors. This is a kind of radar sensor that sends out teeny tiny waves called millimeter waves that bounce off objects and come back. By measuring how long it takes for these waves to return, the sensor can tell us when something's moving and how far away it is. Because the waves are so small, the sensor is pretty accurate. It'll work in the dark, it can see through thin walls, and some can even detect your heartbeat. Let's set up an mmWave sensor in Home Assistant using ESPHome, and then set up an automation in Home Assistant. By the end of this video, you'll be able to set up your own motion sensor to turn on the lights when you walk into a room and turn off your lights when you leave. For this video, you should already have Home Assistant set up and running on your local network. I'll drop a link to all of this in the description below if you want to follow along. You'll need one LD24 mmWave sensor to send data to our microcontroller. This one is Model C, a bit more higher end than the LD2410B. Our microcontroller is an ESP32 to receive sensor data and send it over to Home Assistant. You'll need a computer to set up and flash the firmware onto the ESP32 and a USB cable to do that. Make sure it's capable of not just charging, but also data transfer. You can also use a small breadboard and jumper wires if you don't plan on soldering the connections. All right, let's start by connecting the sensor to the ESP32. We'll connect the VCC power pin on the sensor to the 3-volt pin on the ESP32, connect the GND ground pin on the sensor to ground on the ESP32, and connect the TX transmitting pin on the sensor to the RX receiving pin of the ESP32, and the RX to the TX. These can be any GPIO pins and configurable later, but some of these are reserved for boot or special uses, so make sure to check the pin out for your board. Make a note of which pins you're using for TX and RX on the ESP32, so we can add it later on in our configuration file. Now that the sensor is physically connected to the ESP32, let's install ESPHome. ESPHome is going to help us with setting up the integration and also the communication with Home Assistant. It's a generic pre-made firmware that compiles to support hundreds of sensors that you can then configure with a small bit of config. It's like a bridge that reads data from our sensor and sends it over to Home Assistant in a way that it'll understand. There's a few ways to flash the firmware onto your ESP32. In Home Assistant, you can use the ESPHome dashboard. ESPHome also has a separate website called ESPHome Web that you can use. For this project, I found both of those options to be very flaky and unreliable. So I'll show you how to install ESPHome manually from the command line using Python. I'm using a Mac. This next step is going to be similar if you're on a Windows or Linux machine, but you'll want to check the documentation. Let's start in our terminal window at the command line. Make sure you have Python 3 installed on your computer and create a directory. I'll call mine ESPHome and move into that directory. We'll set up a new virtual environment called venv and activate. Activate the virtual environment. Then we'll install ESPHome. Okay, I saw some errors there, but let's see if that installed correctly. Yes, so we have a pretty recent version of ESPHome. Now that the ESPHome is installed, let's configure the LD2410 sensor and give ESPHome instructions for how to communicate with Home Assistant. I'll include a link to my configuration if you want to use mine, but you'll need to update a few sections with your own details. Now let's set up the configuration file from scratch using the ESPHome wizard. So I'm still in my virtual environment, and I'll say ESPHome wizard. And I'm going to create this YAML configuration file for my office because this is where I want my mmWave sensor to be. And it kicks off the ESPHome wizard. Just 4 steps. So choose a name for your node. This is going to be an mmWave sensor in my office, so I'll call it Office. And choose one of the supported microcontrollers. I know that mine is an ESP32. And as far as the specific board, You might want to look at the specs if you don't remember which board you have, but I remember mine is this one right here, the ESP32 DevKit V1. You'll only need this part. And you'll find your own board if it's different. And you'll want to enter in your SSID for your Wi-Fi. I'm just going to put in an example one, not my real one, just so I don't leak my password. And for my over-the-air password, I'm going to leave that blank for now. So now I have instructions that say, follow the rest of the getting started guide. We could take a look at that in a little bit, but if we take a look in our directory, we can see that besides our virtual environment files, we also have a YAML office.yaml file. So let's take a look at that and make some final edits. I'm going to open this up in VS Code, but you can use your favorite text editor and zoom in a little bit. So you can see that the stuff that we entered into the wizard is now here in this configuration YAML. To set up the mmWave sensor, specifically the LD2410, we'll need a few more pieces. And remember, I'm going to share this config that I'm using with you so that you can copy and paste and then edit it later on. But for me, all I just added was the LD2410 because until now there was no mention of that sensor. The other thing is the TX and the RX pin. Remember, I said make a note of what you pinned, what you wired the sensor into. So the transmit pin and the receiving pin on the ESP32. If you had a really good eye, you saw that that was GPIO 26 and 14. Yours might be different. And then a couple more pieces just to make sure that the LD2410 sensor is communicating properly with the ESP32 and then setting up the actions that we want it to be able to have. And then if you had a real keen eagle eye, you'll notice that I also copied and pasted this part. So this part is missing from the out-of-the-box configuration. So if I just cut that and move it up here, we'll need an API encryption key, and this is so that we can add it to the Home Assistant dashboard. So where you can get that key is on this page here. So we're here in the API for Home Assistant configuration variables section, and you can generate your own randomly generated 32-byte base 64 encoded string, or you can just take this one here. So we'll add that here as our encryption key, and we'll need to keep an eye on that because we'll need it when we set stuff up in Home Assistant as well. So now I'm going to save my changes, and now this office.yaml is going to be ready to upload into Home Assistant. Okay, we're finally ready to upload the configuration file. Make sure your ESP32 is connected directly to your computer with that USB cable that we have earlier. You can see that it's powered on now. And let's go ahead and run ESPHome run office.yaml. Looks like there's multiple options for uploading. I'm connected with USB, so I'll choose the default option. This entire process can take up to 5 minutes, and when it's done, it'll start up and connect to Wi-Fi. Once you flash that custom firmware to the ESP32, it'll start up and connect to Wi-Fi. In Home Assistant, you might have a notification here where you can go check it out, but if you don't see that notification, you can always go to Settings, Devices and Services, and see the newly discovered devices here. And here we have one under ESPHome for Office. You'll want to configure that device. And here's where you'll have that encryption key from earlier that you randomly generated and submit. And you can add it to an area if you want. You could take a look at the ESPHome integration and take a look at one device and all the device information. If you want to add it to your dashboard, so right now there's some attributions, moving target, presence, and still target. If you want to add it to your dashboard, you can add that card to your main dashboard here. Now that we set up our sensor and ESP32 in Home Assistant, let's make it smarter and set up an automation. To set up an automation in Home Assistant, you can go to Settings, Automations, and Scenes, and create a new automation. One of the most popular automations in Home Assistant is front and center. It's called Motion Activated Light by Home Assistant. You can select an entity. This is going to be our motion sensor. And then you can filter on which light you want to turn on. So you can search by choosing a device, an area, an entity. I know I want to turn on a light I call Hugo, Philips Hugo light, and the wait time. So the time to leave the light on after the last motion is detected. So 120 seconds. In about 2 minutes, when I leave a room, the light will turn off. This looks pretty good, and we'll save. This works. To make our automation even smarter, we can create an automation from scratch. So on this page again, I'm happy with my automation, but if we want to make it smarter, we can create a brand new automation from scratch where you can clearly define your trigger. There's more options for a trigger besides just the mmWave sensor going off. Maybe I want a certain time of day or when somebody's home. You can add multiple conditions and a list of actions. Instead of just turning on a light or turning off a light, you might have a group of lights or maybe turn on some music. Lots more opportunity for customization, but I'm happy with mine, so let's test it out now. With the sensor, we started off with a basic configuration. You can still adjust the sensitivity, detection range, and other settings. You can also solder the connections to swap out the breadboard and 3D print a case to hold everything together. Experiment with the orientation and placement of your sensor around the house. And that's how you can build your own affordable motion detector. Once you set up one, you can set up more in other rooms and set up zones. You can save even more money by buying the components from China, especially if you're making a bunch of these. Let me know if you'd be interested in a video showing how I order parts from China. And thanks so much for watching. Let me know if you think I should keep making content like this. I'm going to be doing this kind of stuff anyway, and I love sharing it with you guys. So I'll see you next time. Bye.